Hello, welcome back everyone. Today we are going to talk about adding and subtracting polynomials. So let's get to it. So the first thing we have to know about adding and subtracting polynomials is that we can only add and subtract like terms. To simplify them further, we can't do this with terms that are not like terms. So for example, if we have 3x plus 5x, we can simplify that further to get 8x. But if we have 3x plus 5, we cannot. We cannot simplify that further because they're not like terms. One is a constant and one is a degree 1 polynomial. So let's go ahead and get into some of these questions and find the pairs of like terms. So before I even add this, I'm going to first find the pairs of like terms. So let's see. I see 8x squared and minus 3x squared. They both have x squared. They're both degree 2 and have the same variable, so they are like terms. These two are also like terms because their coefficients are different, but they have, they both have an x attached, right? They both have x. They're both multiplied by x, so they're like terms. And then these last two, -5 and +4, well, those are both constants, and two different constants are like terms as well. So let's answer this question. If we take the purples first, 8x squared minus 3x squared, that is going to be 5x squared, right? So that's our result from the purple. Then what about negative 13x plus 6x? Well, that's going to be negative 7x when we simplify that, and that's a result of our blue. And then for our green, we have +4 minus 5, so that's going to be -1. And so this is our overall answer. The great thing with this, it's pretty straightforward. It's probably the most straightforward part of this entire unit, which is good. People tend to like this part of the unit because really all there is to it is to find the like terms, identify what they are, and then add or subtract them accordingly. Let's go to number 2. And for number 2, I encourage you to pause the video and try this on your own, and then come back when you're ready to take this up. Okay, so let's start with 4x squared minus x squared. Well, that's 3x squared. 7y plus 9y is 16y. And then -3 minus 5 is -8. So this is our overall solution here. Let's try this next one. Here we have 8y squared minus 5y squared. That's equal to 3y squared. Then we have minus 2x squared plus 6x squared, which is plus 4x squared. Then we have plus 4x and plus 2, and those are not like terms, so we just write them as is. We don't need to add them to anything because there are no other like terms. There's only one constant, and there's only one degree 1 term. Okay, let's move on to the next page, which says to subtract the following. This is slightly different because just like earlier we talked about, we have to distribute numbers throughout our brackets. We must distribute this negative sign to all three of these terms first. Whereas when we had the plus sign, a plus sign being distributed does not change the signs. A subtraction sign, the minus sign, it does. So my first step here is going to be to simplify this a little bit further and to say 2x squared minus 15x plus 4, and then we have minus -3x squared, which is plus 3x squared. Then we have minus positive 6x, which is minus 6x, and then we have minus -8, which is plus 8. So making sure we get the distributions correct is important. And now from here, we can just do the same thing as before, which is find the pairs of like terms and add or subtract them. So we have these x squareds, we have the x's, we have the constants. So let's first add our purples, so our terms with x squared that are degree 2. We get 5x squared, then here we get minus 21x, and then here we get plus 12. Very good. All right, and let's do the same thing here. And again, I encourage you to pause here and try this for yourself, and then come on back when you are ready. Okay, so for this one, we're going to have to distribute this minus to both of these, and then this minus to both of these. So that's our first task, is to do that. So we have negative 4x squared plus 6x, and then negative minus negative 2x squared, which is going to be plus 2x squared, then minus 4x, since the negative gets distributed there as well. Then we have minus 3x squared and plus 7x. Okay, so now that we've done the distributions, I'm going to find all the like terms. In this case, there's actually 3 for x squared. There's all 3 of these. And then for x, there's all 3 of these that are all added and subtracted together. So let's see, for the purples, it's negative 4x squared plus 2x squared minus 3x. So that's the same as minus 7x squared plus 2x squared, which is minus 5x squared overall. So that's our overall results for purple. And then for green, it's, well, 6x minus 4x plus 7x. Well, let's see. That is going to overall be, I believe, plus 9x. So we'll put plus 9x there. And that's our results from our green terms. So in this case, we didn't have any constants. Everything was either x squared or x, right? Our terms were with regard to one of those things this time. Okay, let's move on to part C. Part C are some word problems regarding all of this. It says, this first one says, Chris owns a store that sells golf carts. The revenue, R of X, and cost, C of X equations for Chris's store are below. Find the profit function. So profit is revenue minus cost, right? Because revenue is all the money that a company makes. So basically all the money that the customers pay Chris for his golf carts or anything else he might sell at his store. However, he also has costs, right? He has to probably pay the rent, or he probably has to pay for the manufacturer to get him the golf carts and get them shipped over to his store, for example. So there's certain costs he has. So after he gets his revenue, so all the money from the customers, and pays his costs, the remaining money is his profit, and that's the money that he actually gets to keep and use for the things he would like. So let's do that. Let's figure out the profit function. How much does he actually get to keep in profit? Okay, so P of x is equal to R of x, which we know R of x is minus 40x squared plus 2,200x, and then minus the cost. So minus 125x plus 10,000. Okay, so first things first, we need to distribute this minus through both of these because we are subtracting here. We're not adding revenue and cost. We have to take the revenue and get rid of the cost to find what's left over, what's the profit. So this is minus 40x squared plus 2,200x minus 125x minus 10,000. Okay, so therefore minus 40x squared, and then here we collect our like terms, so we get 2,075x are left, minus 10,000, and so this is his overall profit. Now, of course, his profit does depend on x, which is the selling price. So depending on how much or how little he charges, he could make more or less profit, but this is generally the equation. So here it asks a more specific question. It asks, what is the profit for Chris if she sells 20 golf carts? Well, let's see. For what price? Um, so it says X is our selling price, R is our revenue, and C is our cost. Well, we don't necessarily know, right? This is a function. We know the profit for if X is the selling price, but here they just say if she sells 20 golf carts. So we don't know the profit on 20 golf carts because that's not what the variable is saying. The variable X is saying that X is our selling price. So we don't know. So that's our answer. We do not know. the profit for selling 20 golf carts. We need the selling price to use this function, right? That's something important, is a lot of people would just say, oh, P of 20 equals blah, 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 right? Or maybe put 20 for P of X, but P of X, that's our profit. That's what we're trying to find. And X is not the number of carts sold. X is the selling price in dollars. So this is a trick question. We do not know the answer to this. There is no possible way to necessarily to figure this out just from what we know so far. Okay. All right, well, that is everything for adding and subtracting polynomials. Next time, we're going to talk about multiplying polynomials, and then we'll talk about factoring polynomials. So those are our final two topics for this unit. I think for a lot of people, these will be reviewed, but definitely still go check those out. Still go review those. They're very important for this unit, and will take less time, I think, to prepare for than a lot of the other topics in the unit. All right, well, that is everything. Have a good rest of your day, and we will see you for the next class. Bye, everyone.